Okay, in this lecture we'll discuss some parabolic graphs and rectangular hyperbolic graphs. So first graph is f of x equals x raised to power 2n, means power of x is even natural number, like y equals x square, x raised to power 4 and so on. This graph passes through origin x equals 0, y equals 0 satisfies this. Because power of x is even number, so graph is symmetric about y-axis. Okay. Now second, f of x equals x raised to power 2n plus 1, which means y equals x cube, x raised to power 4 and so on. Power of x is odd and likewise power of y is odd. Graph is not symmetric about y-axis, not about x-axis, but this graph is symmetric about origin, opposite quadrant, because if you replace x with minus x, minus y and minus x cube equals minus x cube, minus cancels out, so the graph is symmetrical about origin, opposite quadrant. Okay, so I've given you one good question here. We need to draw the graph of maximum of x and x square and x raised to power 4. So what we do, we draw x square. Okay, this is x square, and if we solve, x square equals x raised to power 4, which means x square minus 1 equals 0. So points are 0, 1 and minus 1, which means x square and x raised to power 4 intersect at 3 different points, 0, 1 and minus 1. Okay, so this is the kind of situation we have here. Okay, this pink one, orange one is x raised to power 4. So between minus 1 and 1, this red color is beneath this blue color, and beyond this point 1 and minus 1, x square is over x square. X raised to power 4 is over x square. So when we need to draw the maximum, we need to calculate the value which is higher. In this case, what we have is maximum. In case maximum, so x raised to power 4, x raised to power 4 and then x square. So x square and then x raised to power 4, x raised to power 4. This is the graph of maximum of x square and x raised to power 4. Minimum will be exactly opposite. Again, I have given you 3 questions: maximum of x and x cube, x square, x5 and something. Okay, and these two graphs are inverse of these two graphs. Like first is f of x equals x raised to power 1 upon 2n. In a way, y equals x raised to power half. This is x square and this is x raised to power half. X raised to power 4, x raised to power 1 by 4. This graph is inverse of this graph. Okay, and how do we actually say why this graph is inverse of this? We need to study functions and inverse of the functions. We'll cover that part later on. But how do we draw? First we draw these two graphs. Okay, so draw f of x equals x raised to power 2n, and in this particular case draw y equals x raised to power 2n plus 1, and then take the reflection of these two graphs about y equals x line. But in this particular case, because x raised to power half, x raised to power 1 by 4, 1 by 6 will be defined for positive values of x, and this graph will be defined for all values of x. So draw these two graphs and take their reflection about y equals x, like x raised to power half. So I have drawn y equals x square. Draw y equals x, negative part we don't really require that. So take reflection of this part about y equals x line. Now this part x square is convex, but this is concave, so convexity changes. Again, what y equals x cube. This is y equals x cube, this is y equals x. We need to draw y equals x raised to power 1 by 3. Then take reflection of this yellow. Right, again convexity changes. So this is y equals x raised to power 1 by 3. This particular graph exists only for positive values of x. This exists for x real numbers. Now rectangular hyperbola, in a way, x raised power m into y raised power n equals k. K could be positive or negative. So first graph is xy equals 1. Graph power of x is odd and y is odd. When x increases, because product is constant, so if x increases or y increases, the other one would be decreasing. Inversely proportional relationship between these two. These graphs are symmetrical about origin. X with minus x, y with minus y. So you need to draw for any quadrant, and then you can check the symmetry of these graphs. So xy equals 1 graph exists in first quadrant, likewise in third quadrant. Suppose xy square equals 2, y square is positive, x has to be positive because y is square, so graph is symmetrical about x-axis. This is the situation. X square y equals 100. We don't need to precisely locate the point of x and y coordinates. We just require the shape of the graph, behavior of the graph. So it doesn't really matter if it's 1, 2 or 100 or 1000. What matters is positive values or negative values. What matters is their powers. So x square will be symmetrical about y-axis, first quadrant and third quadrant. Suppose x square and into y raised power 4 equals 1000. Graph is symmetrical about y-axis, symmetrical about x-axis because powers are even. So first quadrant, this graph exists in first quadrant, and likewise we can use the symmetry to draw this. First quadrant, second quadrant, third quadrant, fourth quadrant. Suppose x raised power 101, which means odd, y raised power 202, which means even, equals some negative number. Because y is even, the graph will be symmetrical about x-axis. Because this number is negative, x has to be negative. So graph will not exist on positive side of x-axis. Draw this graph in second quadrant and use the symmetry of this graph. That's it. And we will cover rest of the graphs in next lecture.